And with that, we will start an introduction to Frame. So what is Frame? Frame is a Rust framework to more easily build Substrate runtimes, right? And you've been learning already for a while now about Substrate, about this blockchain framework, and about this client runtime interface, right? But the runtime has mostly been this kind of opaque object. I mean, I think you, in the last project you worked on, you were interfacing with these runtime APIs and building these things, but I hope you think that that was a very painful exercise. What we're going to show you here is, what if there was this amazing framework that could make this all easy for you, that could handle all of these behaviors, that could just make things work, right? And that's what Frame is. Frame will make your life easier, will make this process easier. Okay? So what is the easiest, most concise way you can explain Frame? Well, I think it's this. There's this palette called sudo. You don't really need to know it right now. But without Frame, it would take 2,000 lines of code to write. With Frame, it's 310. It's 7 times smaller. And this is not even the most crazy example. This is just a practical example. In the context of all of Substrate, Frame reduces your code base by tons and tons and tons. Compared to other SDKs that don't have the power that I'm going to show you with macros and these other SDKs, you have to write so much boilerplate code over and over. With Frame, we handle that for you automatically and do it in a Rust-safe way. And this is very powerful. All right? This enables you to write safe code faster and build what you want faster. Right? This is the big sell of the Substrate framework, and very much the under the core ideologies of what we want to do with Polkadot, and be able to enable developers to build what they want fast and quickly and securely. What are the goals of Frame? Well, we want to make it easy and concise for developers to do development. We want to provide maximal flexibility and compatibility for palette developers, right? Allowing you to configure as much as you can. Provide maximum modularity for runtime developers, right? So when you built these palettes and you actually want to build a blockchain, you put them into your runtime, as much flexibility there as well, and to be as similar to vanilla Rust as possible. Now I want to mention that these goals are actually quite hard. You know, when you're building a framework, usually you're making a trade-off between how flexible it is and how easy it is, right? The more flexibility, the more configuration, the more options you have, usually the more complex the framework gets, right? So we're trying to find a nice balance between the two here. But of course, we want to make sure that we're not just telling you this is how it has to be done. It has to be done this way. You have no option to change it. And then we have a bunch of cookie cutter, exact same blockchains, right? And to give some context here, you might have heard hints about this, right? But with Frame, we are able to create blockchains that are built using all the Substrate Polkadot primitives, but also build blockchains that are exactly able to emulate the EVM. The flexibility is quite high in this space, right? And so the complexity is a little bit high, but I think still much, much simpler than what you would get off of building your own, low-level runtime. And this last one, the history of Frame is very interesting too. As you might know, Dr. Gavin Wood, he was he was the inventor of Solidity, which is the kind of custom language for smart contracts. When we were first developing Frame, it was called SRML, the Substrate Runtime Module Library. This is way old stuff. And I think his original approach was build another EDSL, build another custom language for building this stuff out, similar to Solidity. I think one of the things we realized, is that we should take advantage of the fact that Rust is already such a strong, robust, and well-known framework, right? Tools like Rust Analyzer, tools like all the macro stuff that we have, compatibility with the different code editors, even just knowledge of the language itself is super valuable. Now, as soon as we build a new language, we force users to learn Rust and learn some secondary language. Instead, if we can keep these SDKs as close to Rust as possible, then we are able to build on top of your existing knowledge, right? Make it easier to approach these things. And so you'll see as a philosophy of what we do with Frame is trying to keep things as rustic as possible. And thank God Rust actually is really good at this. I mean, better than any other language, really. So you'll see that with the Rust macros coming up, okay? But these are really important philosophies for how we are approaching building Frame, right? And I want to mention one last thing. Of course, I think as Keon and me, Joshi, has mentioned to you, Frame is just one opinion of the runtime. The runtime itself is whatever you can build to WASM, which follows these APIs, will work. You all did it yourself. We have one opinion of how runtime development should look like, right? This is not the only answer. I actually, I'm still waiting for someone to be brave enough to go and make their secondary framework, make a second competitive frame, which could be more simple, more opinionated, or even way more crazy, way less opinionated, right? Either side would be useful in our ecosystem. But this is just one example of that, and I hope by learning Frame and learning all this stuff you have, you can keep in your mind this was an opinion that we made, and this is something that you don't have to follow if you don't want to, right? You can change things if you wanted to.
Excuse me.
Yes.
Hi. Usually people don't get to see us. I'm Sukhmeet.
Hey.
Challenge accepted. We'll get the lines of code to 10.
Sure. You can do it.
One of the things that we're doing is writing a book because, with due respect to Dr. Gavin Wood and you, I think, and not to deviate or take too much time, Parity has very good Rust developers. And the barrier to entry, they don't even use Rust properly. So they use it, and then also Frame. It's supposed to be, there is, like, why can't you just drag, drop, and create a parachain? Why can't you have a plugin for the IDEs? There are only two IDEs, VS Code, most of you guys use it, Codium, or Rust Rover that's coming up from the IntelliJ line of. So there is a lot that is not ready for developers.
Yeah.
Like, that's not a comment, right? That's a,
Right.
So we are going to help solve that.
Amazing. I totally agree with you. I think one of the ways to frame this context is, and I absolutely agree with you, that there's a lot of room for improvement. That Frame is the product of our goal in parity development. And the goal, yes.
So also I looked at your background and Dr. Gavin Booth's background from Microsoft. So I think we are on track
Yeah,
because
sure.
they are the best guys at it.
Yeah. But I want to say that the goal we had when we were doing all this was not to build an SDK here. It was to build Polkadot, right? Now, obviously, in the goal of building Polkadot, if we could go down the path of, okay, let's build all these Rust extensions, let's build all these VS Code extensions, let's build all these things, we wouldn't have made Polkadot. We wouldn't have got to the end point. So I think we're really relying on educational programs like these to train you to be able to do what we can't, which is, bridge and make those tools which are easier. Leave us to build this complex, relay chain, heterogeneous sharded network. Let's have you all who can actually take these reins and bring it forward. So that's great. I'm glad to see that this is something that, I want to see more of, okay? Okay, let's talk about the building blocks of Frame. So we have Frame development, which is composed of these palettes and macros. And then we have other parts of Frame, which is these coordination pieces, things that you don't necessarily touch, but you are kind of required to use. This is called Frame System, Frame Executive, and the Construct Runtime. And we'll kind of go over these one by one, but I just want to give you a high-level overview. These are the main building blocks that you'll see when working with Frame. So first, palettes. I think Jimmy already mentioned this a little bit. Hopefully, I think, through the knowledge you might have about our frameworks here, palettes are basically our opinion on how the runtime should be developed and constructed. You could build a runtime which is just one giant blob of logic, right? Every single piece is all one thing. And in many blockchains, that's kind of what they did for a long time, right? But we don't think this is a very scalable or manageable code base, right? Like, imagine I change one thing here and you have to, it affects the whole of all of your runtime logic. It just doesn't make sense. Instead, what we believe is that you want to compartmentalize the different pieces of logic of your blockchain into these different things called palettes. So you might have a staking palette. You might have a palette which manages just the balances of users. You might have a palette which manages democracy or open governance. You might have a palette which helps with consensus. These different pieces of logic could work together, but more often than not, they're separate logic. They're completely kind of fragmented or in their own little box. And so being able to design your runtime with putting these different palettes together into one cohesive system and connecting them where they need to be connected, we think that's a great vision for how to build a runtime. And so when we build Frame, we have in mind always the construction of a palette, building some unique piece of logic which has its own goals and could interface with other palettes, right? And they, again, all come together in the runtime. But I want to mention this. Once you compile your code, right, it's not like you have 20 WASMs spit out that you upload to your blockchain. It all becomes one runtime. It all becomes one piece of code. Rust merges everything together. But again, you're importing crates and you're bringing things in. They're kind of separate. So that's the palettes. So what are the building blocks of palettes? Well, there are a few different parts. The most common one you might be familiar with are these dispatchable extrinsics. These are also called calls. So when you do like balance transfer and you pick like to who and how much, that is a call or a dispatchable extrinsic. There are storage items, right? every blockchain basically is a database, a distributed database, right? So storing information on the blockchain is important, and being able to control what you store is also important. So storage items. And then you're gonna have, this is pretty unique for palettes, hooks for things. So like block initialization and block finalization. By the way, yeah, this is not the same as block finality. So this is maybe poor on us for wording here, but there's this idea of finality in consensus. You learned about that. What we mean here is at the end of the block. So at the beginning of the block and the end of the block. And so like if you're building a smart contract, you don't actually have hooks like this. You're waiting for a user to submit some transaction to initiate some logic flow. When you're building a palette, you're working at the low-level runtime logic of your blockchain. You're able to actually create logic which says at the beginning of every block, do this. At the end of every block, do this. And it can happen automatically, even if there are no transactions in that block, right? It's just your blockchain can have its own brain thinking. So these are things that are available to you in palettes. And there are many more hooks than this, but these are just the ones that are most common. Okay? Yes.
We are going to learn just the part of the runtime, so we are not touching anything related to the node stuff.
Yes, and actually someone asked me that earlier, and that's a great point. When we go into Frame, we are talking about building a framework for building runtimes easily, right? This goes to the philosophy of Substrate, that as you've learned, there's a client and a runtime. The client, truthfully, is a way more complex beast. It has things like the transaction pool. It has all the database layers. It has this peer-to-peer network stuff. It's managing multiple different histories of the block. Like the block could be in different forks, and it's managing all that at once, right? That is hard work. That kind of stuff, we want to give it to you, and in most of the cases, it's all the same. The one thing where we believe there's differences in how people want to build their blockchain is the runtime. That you probably don't care about what P2P network you use as long as it's secure, what exact hashing algorithm you use as long as it's secure as well. What you do care about is, hey, can I build my game? Can I build my identity layer? Can I build my application? And that's where the runtime comes in. So no, we're not going to teach you anything about the building a client, and truthfully, that's kind of outside of the scope of what we want people to do with Substrate. Of course, you can do it, but primarily we're focused on, hey, runtime is really the entry point for developers to easily build things. And within the runtime, you're in a much more safe and simple environment where there's only one truth, you have one consensus, you have one view of the world. Okay? Let's talk about some more building blocks of palettes, right? So these are kind of the less important ones from the ones I mentioned. So you have things like events and errors. These are ways to announce to the world when things go right, when things go wrong. You have custom validation and communication with the transaction pool. So as I mentioned, the transaction pool does exist in the client. There are a lot of things that exist in the client where you can actually hook into it from the runtime. But these are kind of, scenarios that we have specially organized between the client and the runtime. We have things like off-chain workers. These are kind of very misunderstood, but the idea is that you can provide additional logic along with your WASM that could run on every node out there, and a lot more. And you'll learn about all of this, either here or throughout your history in building on Substrate. But these are all kind of the core building blocks of palettes. So let's look at a shell palette, okay? And you'll all be working, so the tutorial I want you to do will start with this exact shell palette, and you'll fill in the blanks and figure out and see what a full palette looks like. But let's look at the shell, right? Basically, it looks like Rust. It has these macros in here, which kind of does some magic, does things that makes things simpler. But you can see here we're importing some dependencies. We have this main struct called palette. This is where most everything is built on top of, right? And then we have these different macros for the configurations, for events, for errors, for storage, for calls. And basically, this is what a palette looks like. It is a just simple Rust module that just contains a palette struct and then allows you to hook things on top of it, right? And we'll see more of that when you guys actually start building your own palettes. So, as you can see, a big part of building palettes and what makes Frame so easy to use is the macros. So macros are basically things in Rust which allow you to write and generate code, right? It's Rust code that generates code. I assume everyone here has some exposure to macros, right? I think through the your entry exams and maybe through some of the stuff in the academy so far, right? So I think you can see how kind of powerful macros can be, and you'll see even more so in this case. We use macros to simplify the development of palettes. We basically all this boilerplate code, all the redundancy, all the assumptions, we can basically implement things automatically using macros. But the important thing about macros is that ultimately it generates real Rust code. So all of the benefits you get from Rust, the safety benefits, all of the guarantees, even the speed, is all happening. Is still given to you. All of it happens at compile time. This is a really powerful thing. So as I mentioned, you have many, many lines of code. It becomes something smaller, but it's basically the same. And we'll look more closely at all the attribute macros that I showed before here. Like all of these, again, are macros throughout the entire course. Yeah, and again, if you want to get to the same metric that I did, you can do this with every palette. Even maybe if some of you are working in paired chain teams already, you can look at your own palettes and how much macros are saving you. So you can see here, I have the number of lines in the raw palette using frame. It's 310 lines. And if I do cargo expand, this basically expands the macro into the raw Rust code. You see the number of lines is 2,000, right? Now, again, this is not the most perfect thing. If you look at this cargo expanded file, you'll see it, it could be formatted better. But practically speaking, there's a lot of code that you're not needing to write, which is being written for you and being written perfectly for you by these macros, right? Very powerful. Okay, so we talked about the building blocks. Now let's go into, again, the parts of frame that you have to use along with the palette development. The first one is frame system. So frame system is a palette, but it's a palette that we assume exists whenever you use frame. So any palette you build has a dependency on frame system. And frame system basically has all the most basic pieces and information that you need for your blockchain. So things like, where is the block number stored? Where is which hash type you use on your blockchain? What is the current, what is the current block head? Like all the information you'd expect on a basic blockchain, this is all being provided for you in frame system, a palette that we've written for you, right? So again here, block number, accounts, hash, etc. All of this is being provided for you in frame system, and you have access to them in your own palettes, and you'll be using them. So for example, I'm sure in all of the projects you guys work on, if you want to know what the current block number is, you would call frame system, the palette struct, and then call the function block number. It will tell you what the block number is in your palette, right? This is the way you can actually get the information that you're looking for. So all that is being managed for you automatically in frame system, okay? And this is an assumption. We assume that you have to use this palette whenever you're building something in frame. Then there's frame executive. This is not a palette. This is more of a coordinator. Frame executive basically handles the execution logic for your block, for your runtime. So it does things like, as I mentioned earlier, these hooks, on initialize, on finalize. Frame executive decides at the beginning of the block, I'm going to run the on initialize hook. Then I'm going to run your transactions. Then I'm going to run whatever. Then I'm going to run the on finalize hook, the end of block hook, and do that. All of the logic, all of the step-by-step process is decided by frame executive. And I'm sure many of you have questions in your head. I would love to just better understand when a transaction comes in, what is exactly the steps happening. Frame executive, you look at the code, it's actually quite simple to follow. You can literally see step by step when we're validating transaction signatures, when we're actually taking away fees, when we're actually running the block at the beginning, when we're actually running the transactions, all that stuff. All that stuff is just step by step happening in the executive. So it's defining that process for you. So that is another piece which comes with frame. And so when you build a palette and you add an uninitialized hook, it works because frame executive is allowing it to work, because it is in the background coordinating that execution. Okay?
Question.
Yes, please.
I might be getting ahead of myself here, and this is coming from someone that's completely unaware of the frame. Is from what you've explained, I feel like frame is just like a module with some like specific requirements or like specific openings or implementations that you have to do, but maybe that's not what's intended, right? Like, what's frame exactly taking into account when you're developing? Like, are you just like modifying the initial base case frame, or what is?
Yeah. Okay. So this, I think that's a great question. I think it will become more clear to you when we actually do the thing. But what I really want you to take away is that frame is an SDK. It is a bunch of different things. It is both like these macro language that turns some small code into big code, but it is also like these utility crates, which you're including into your base runtime, which is doing things like managing block number, managing execution, etc. So frame isn't just one thing. It's actually many things, right? And I mean, you might even say frame is actually even the whole ecosystem of palettes. So if you want to build a new blockchain, there are many pieces that already existed that you can grab. that is part of our overall frame ecosystem. These palettes which already exist from either built by Parity or built by parachain teams, which you can just pull and use automatically. So I would say all of that is kind of frame. But it starts with basically some assumption of how we want to construct and design a runtime.
Okay, and just as a follow-up, so could there be like a, let's say a baseline? Like you say, Rust is the baseline language. You do what Rust allows you to do. Is Frame also, does it have like a baseline palette that where you can like start building from that?
Yeah, we have a template, and you'll use the template in the
I don't mean as a template. So I mean like the what's available for you, like what's possible for you to do with that.
So I didn't understand actually. Can you say that one more time? So you're asking what is possible to be able to do with Frame?
No, is there like a baseline of what's possible and what? How do you get around those limitations using that? That's my question.
It's their baseline of what is possible. So I think throughout this course, basically learning Frame is learning what is possible. Like I'm going to teach you about storage. I'm going to teach you what kind of storage things are available. I'm going to teach you about events. I'm going to teach you the limitation of events, how much events you can put in your storage, how big your errors can be, etc. Like those are all the limitations. But what I want to mention to you is this. These are limitations imposed by an opinionated framework, which is Frame, that you know already an idea of the limitations of the runtime, because you've been building in the runtime. You know that basically you have to build some WASM, but beyond that, it's kind of whatever you want, right? So, yeah. But again, this is learning Frame is basically learning all of how it works. I think that's the
No,
idea.
yeah, definitely. That's why I say I think I'm getting ahead, but I just wanted to get
I would say keep where your head is at. We want to complete the first tutorial, and a lot of things will concrete themselves.
Definitely.
Yeah.
Thank you very much.
Yeah. One more question here, and then we'll keep going.
Shawn, for the previous slide where you talk about the config, and you mentioned that that's where you define the accounts and the hash. Is it that's where, for example, if I wanted to add P256K1 versus, 256R1 instead of K1, is this where I will essentially?
I assume those are cryptography, right?
Yeah.
Yeah. So actually, in Frame system, there is somewhere in there where you can pick which cryptography you want to use, and that's where you would define it. Yeah, and it would be in this config. And actually, if you remind me, I'll show you that
Nice.
when we open the code.
Nice. And I'll ask you more. Thank you.
Okay. Yeah. Okay. Let's keep going. We're almost there. Okay. We did Frame executive, right? Now construct runtime. This is the last piece. So once you've created your palettes, right? We want to put them together and have them work together inside of a single runtime, right? The runtime is one kind of object, right? And so construct runtime does this. This is a macro, which you can see here, there's a struct runtime, and we basically stick in it all the different palettes you want to include in your blockchain. This is actually what the palettes look like for a template runtime. So it has all the basics. It has your system, which we, again, assume always exists. It has timestamp, it has stuff for consensus, it has balances, it has transaction payments, transaction fees, right? And even a template module here. And so you put all of this stuff together, and bam, it constructs a runtime for you. It generates tons of code for you that makes everything work. And like a lot of the stuff you saw in the background, all of this high level transaction encoding and handling fees, like whatever you guys did in this last project, it does it automatically for you. Again, we made you suffer so you can appreciate more what's going on here, okay? And I hope you really, really will like it. But construct runtime is kind of the last piece of actually putting these palettes together into a single runtime and generating it. Inside of that runtime file, you'll also have configuration. So there's this so palettes, again, we talked about palettes being maximally flexible, not only for palette developers, but for runtime developers too, right? So your role in the ecosystem could be to generate really cool ideas, these really cool palettes. And then it could be that other ecosystems, other runtimes, other parachains will you take your palettes and put it into their runtime, right? If you build something really cool. Now, of course, you would want to be able to expose configuration. For example, let's say that you made a really cool multi-sig palette. You might want to configure what the fees are or the maximum number of signatories or whatever kind of stuff you want to have there is. You can do that. So in your palette, you can define in this config exactly what kinds of configuration items you want to be exposed as your API to the runtime developer. And then in the runtime, you concretely define what you want. So for example, here, this is the config for, I guess, the timestamp palette. And timestamp has the idea of moment. What is the units of time? And you can see here, we have some requirements that it must follow these traits. Inside of the runtime, I say concretely, this is going to be U64, right? But someone else could use this timestamp palette and use U128. They could use whatever type they want that fits these constraints. So this allows you to be flexible in both the palette development and the runtime development, right? So this is kind of what's happening. And exactly what you mentioned here, if you want to, in a frame system, we have the ability for you to change things like the cryptography. If you want to change the signing scheme, if you want to go to Blake 3 or whatever kind of thing you want, you can actually configure that. So again, flexibility to both the developer at the palette level and the runtime level, right? Okay, so we're not going to do this exercise right now, but I think, probably the founders are going to leave before we actually get to do this in person. But I recommend that founders actually try this themselves. Again, it shouldn't be that complicated. It's meant as an intro. You're mostly seeing it, but we will take basically in this example. Maybe open the link. We take exactly this skeleton template that I showed in my presentation, and we fill in all the blanks to generate a very simple proof of existence runtime. So basically, you will actually go and create your first palette. And being able to complete this tutorial successfully will ensure that your computer is set up correctly for building the node template, for building a palette, and that you kind of have a sneak peek into what the macros are doing here. And of course, throughout the rest of this course, or throughout this rest of this, what do we call it, the section, I'll tell you more details about all of these things, what you can and cannot do, how it works, etc., right? But this is very much a good starting point for you to get an idea of, like, this is kind of what it looks like. And again, answering to you, what is Frame? This should help answer that idea. So this is something that you will have time for you all to do today. Should take about an hour, and then etc. So one more thing I want to note, there is another project that, because tonight I'm giving the Frame exam, but because we haven't really taught any of Frame yet, we're not expecting you to code, we're expecting you to think. But I do have this exercise, which I'm still fixing some little things here. But it was this Rust state machine. I sent it before. Who actually did it? Did anyone? Okay, not enough. Again, this is not part of the course. I think you will do fine if you don't follow this. But I have built this because I have a belief that all of the hardest parts of Substrate and Frame could be solved by just understanding more how these things were designed. So this tutorial here, I'll send a link for it later today. If you have the ability to walk through or just read it, I think will level you up in your ability to comprehend and understand what's going on in all of the complex Rust aspects. This project starts with a Rust hello world. And literally, let's see if it goes here. It starts with literally initialize Rust project, a hello world, like a brand new Rust initialized project, and takes you through the process of creating the idea of palettes, introducing things like the system and runtime, making things generic and configurable, and then all the way to actually adding macros and then seeing that final process. So, and we do this all without using Substrate and Frame at all. And if you can follow this, I think you're going to understand a lot more deeply how Frame works. But again, this is not a required part of the exam. It may not be that you have time to finish this. That's okay. But I do recommend if you have the resources and the time, just to read through it, and I think it'll be very helpful to you. Okay. So when after the end of the day today, I'll send a link to this project. Okay. But I think next, before we go in here, I think Keelan wanted to give some feedback and talk about some tips and tricks in Frame, and we'll keep going from there. Okay. 5-minute break. Oh, yeah. Sorry. Questions, of course. Yeah. Questions, of course.
Actually, let's go break and I can ask them.
Sure. Absolutely. But any questions you want to ask public? Yeah, please. Can someone pass a microphone back there, please? Thank you.
Yeah, more on off-chain workers with example and limitation.
Yeah, off-chain. So, off-chain workers. I mean, let me see. I think off-chain workers are very misunderstood. Off-chain workers, people believe they can do things with them which break the rules of blockchain and runtime. Things like, for example, querying HTTP endpoints, getting data from an API. You can do this with off-chain worker, but it's not all of a sudden that you can do this and you have a consensus safe logic, right? The main idea of off-chain worker is this. Imagine that I wanted to build some kind of sidecar application, some kind of application that runs alongside the node. For example, let's say that you wanted to build something where every single time some address receives a token, that it pings you from an HTTP endpoint, like, hey, you got a token, right? One way you could do this is you could have your node running, you could build a Node.js application on the side of it, and it listens on the APIs and then does the thing. What if instead of building a secondary application as a secondary binary, you could just include some additional WASM in your existing WASM payload, and the client, which is running your blockchain, could also run the sidecar application, right? That is what off-chain worker is. So an off-chain worker is basically the exact same thing as running two applications, but just bundling it with your WASM. And there are benefits to this. The benefits to this is that I could, for example, have some logic which I want to share with my whole community. Maybe everyone who's running a node should have this little piece of logic. I can then deploy this off-chain worker logic along with my runtime, right? So it kind of allows me to bundle things all in one. But it does not allow for, and this is what kind of it hurts me, and it pains me when I have to explain it to people. It does not allow for magic. You can't all of a sudden query HT endpoint, pull in the price of Bitcoin, and say this is a consensus, decentralized form of information, right? That's not how it works. But you can do things that a runtime normally can't do. You can talk to the outside world. You can do stuff because it's just a secondary application built in WASM, right? Now we won't really go into off-chain workers here in this class. But if there is some kind of idea that you have that you think off-chain workers will work for, I'm happy to talk with you more one-on-one, or maybe we can make a thinking session or like lunch session where we can talk about it and we can learn more about it. But truthfully, my opinion is that off-chain workers probably cause more confusion than good at the moment. If you're going to build something with off-chain worker, build it as a Node.js app first, and then after that, we turn it into Rust, right?
Thank you.
Really quick, what is the use case for changing the timing system? I think there was
The timestamp.
the timestamp, yeah.
Sure. So, I mean, I think knowing the time on a blockchain is pretty relevant. So there's a few reasons. Like, for example, when I'm importing a block, I might want to make sure that the block I'm importing was built after the last block on the blockchain, right? That's I think every blockchain,
okay.
And if you actually look at the Bitcoin white paper, the Bitcoin is a timestamp server.
Right.
So in this context, it's that. Now, timestamp is not a consensusable information, right? That my time on my computer and your time on your computer is not exactly the same. There's no way to prove it. But I think within the idea of importing blocks, you can know, relatively speaking, that this block was made within the last couple of minutes. It makes sense to you. You can kind of get an idea. And then, of course, if you're building an application, it might be useful for you to know that some time has passed or whatever, and timestamp might be relevant.
So it would be like a mixture. You could do a mixture between block number plus a timestamp, and then
Yeah.
Okay.
Tomorrow, I will go over a bunch of different palettes, and one of them will be the timestamp palette, and I'll show you kind of how it works, because it doesn't work like a traditional palette, because it takes some information which it's hard to get consensus over. So it's an interesting palette to look at. We'll do that
you.
tomorrow.
Thank you.
Yeah, more questions.
So for off-chain workers,
Yes.
we are working on making basically Web 2 games transition to like Counter-Strike, transition to Web 3 we are not targeting NFTs, we are targeting the UX. So for us, if somebody puts in a resource and we will optimize it, we would use an off-chain worker to optimize the assets so that they can be going on different, like if it's a Twitch channel, it can be connected to a phone.
I think that's a more complicated conversation. I think we can have it,
Yep.
one-on-one, but could work. I'm not 100% sure.
It's not to put the emphasis of compile like code execution load. Like what if we want GPUs, host of GPUs to process the images, right?
So this is where, okay, so I should mention here. So he mentioned GPUs to process things. This is where confusion starts happening because, again, GPUs running on your local computer, whatever, still need to come to consensus with the rest of the network. You still need a bunch of other GPUs on every other machine to be able to verify the same stuff. So, you can't just run some off-chain worker on one machine and expect it to get into consensus with the network. So, again, maybe a conversation for us to have outside of this.